No, it's not. A squared plus B squared equals C squared. What are those? Agreed. Good luck with that.
Okay, so if you would like to take a few notes during this, I'll say again you can. You don't have to. I'd suggest writing a few things down, but we're going to be talking about one equation today. Before we get to that, though, we're going to talk about what is density. So before we get started, there were two things I said had to be the case for something to be considered matter. Does anyone remember what those things are?
You literally just...
Something to be considered matter.
Could you not?
Has to take up space. Yes, if something to be matter has to take up space. What was the other thing? Jesse.
Yes.
What do you know?
Oh, it's volume density times mass.
No. What is it? To be considered matter, it has to, something has to take up space and what?
Volume. Or mass. Wait.
Nope, you said it. Say it again.
Volume.
Nope. Oh,
mass.
Mass. It has to have a mass. Alright? So taking up space is basically volume.
He's videotaping me.
Okay, so to be considered matter, you have to take up space and have a mass. Those are two things you'll need to know. Okay, all matter has to have mass, has to take up space. That's why remember I said you are matter, because you have mass and you take up space. But now we're going to talk about density, which is the makeup and the structure of all matter. So when we're looking at all things that have a mass and all things that take up space, we talk about their density. So then my next question, I guess, is are you dense? Okay, so we've established that you're matter. Put that away for now.
Could you stop videotaping me? Thank you.
So we've established that you are matter, but also we need to establish that you are dense. Okay, so density is two things. Alright, so to be considered dense, alright, you have to have the following properties. You have to be made of matter, okay, and you have to have a volume, which means you take up space. Alright, density is a ratio. It's a ratio between the amount of matter in a space and the amount of space that item takes up. Okay, so once you've identified something as being matter, you can identify what its density is. Right? And you probably experienced more with density than you thought of in your life. Okay? So must be made of matter, must be considered matter, and must have a volume. Okay, so it has to take up space. When you combine these two things, mass and volume, you get density. Here's the official definition if you would want to write that down. Okay, it's a measure of the amount of matter that occupies a given space. So how much matter or material is within a specific location, right? Density differs based on the item. So for example, I could have a huge gold bar. I don't have a huge gold bar, but I could. If I had a huge gold bar, it could be very, very dense because it's big and it's got a lot of weight and it takes up a lot of space. Right? And that same density of that huge gold bar would be mimicked in just the tiniest piece of gold. Because the ratio of how much mass to how much space is the same. Right? So density is all about a ratio, the amount of matter within a certain spot. I'll give you a second if you write this one down, and I'll kind of give you an example, which hopefully makes more sense. I want to just round. Cleaned out the fish tank too, so the lobster's almost there.
Oh, so it's the lobster.
The lobster.
You never told me.
Oh, you were here.
Oh.
Yeah.
Which one?
Wait, I wasn't here.
We're getting a lobster. All of us are getting lobster. All of us.
Lobster?
And a ball python.
Oh, both of them?
And a python?
Let's go.
Carry it on my
Let's go
arm?
cook the lobster.
Go!
Let's go cook the lobster. I'm hungry.
I don't care for cooking.
Snake can't swim.
What's that one lobster's name or crab or whatever?
Okay, anyway, we're gonna move on. Sorry, I'm distracted.
Have you seen a
Right,
lobster
so
furry?
when we are looking at density, right, I'm gonna point some things out. It can be easily confusing, right? But what density is the idea that different substances have the same can have the same mass, but they don't necessarily have to build the same amount of mass.
Maybe Isaac.
But
Look, you got a solid cubic. Well, not cubic. It's
You're going.
tropical. No, not tropical. It's a.
This will be. Let me give you the worksheet we're gonna do. Okay, so I'll post this after we're done going through it, and then this is what we're gonna work on. We're gonna go over it.
What's a one-dimensional
Strawberry
cube?
honey bug, we're gonna go over it. Okay.
Thank you.
Yep. Okay, so
Square.
sorry guys, that was a little break. We're gonna return back to the fun notes we're doing. Alright, so different substances that have the same mass, they don't necessarily fill the same amount of volume. So what that means is, even though you may have two items that have the exact same mass, as shown here on this triple beam balance, they do not have the same density because their volume is not the same. Okay, so what that means is if you look here, do you guys know what a triple beam balance is? I asked. You do? So if I told you like you have to use one, you can do it? No? Anyway.
Is that it?
Yeah.
Oh, then
Okay, so if you look here, guys, let's hold our conversation so we can get through this, please. Okay, so if you look here, these two items have the same mass. These two balls here compared to 1, 2, 5, 6, 7 here, they're showing is the same exact weight. Alright? But if we look at them, we can easily tell there's much more volume here compared to these. There's 2 versus 7. Right? This is a big role when we come to density. Even though these two have the same mass, right, their volume is not the same. So if you take one of these blue colored balls and you put it beside this yellow colored ball, this blue ball is going to be much more dense than the yellow, right? Because the volume is much smaller. Alright, so same mass, different volume, totally okay with density. Another thing that can occur is we can have the same volume but a different mass. So if you look at these 3 cubes, they're all exactly the same. Right? Their volume is the same. This foam block, this wood block, this concrete block. So we know, based on what their labeled is, they don't have the same density. Alright, even though they are the same exact volume, they have different masses. This one is foam, meaning it's much, much lighter. This one is concrete, meaning it's much heavier, and wood in the middle. Alright, these two features, mass versus volume, are what change the density. Okay, that's why everything the same size is not the exact same mass. Right, and that's why everything the same mass is not the exact same size. It's different density. So it's the measurement of how much mass is within a specific volume. And one of those features can be the same, but when one's different, it creates the different densities. Okay. One last thing before we go over the equation is mass versus weight. So a big thing you need to know, because a lot of people say this wrong, is that when we talk about mass, we are not talking about weight. Okay, so they are different things. Weight is based on your gravitational pull. When you go to the doctor, you take a step on the scale and they measure your weight. All they're measuring is the amount of mass you have, how much is being pulled down toward the earth. Right? If we were not on Earth, say we were on the moon, like this will do right here, there's less gravity. And therefore you would weigh less. Okay, so weight is not the way we really look at things. That's why we use mass. Right? So weight is equivalent to the force of gravity. That's why when you see like moonwalking people, they're like floating around, because they barely have a weight, because there is no gravity to pull them down. Right? But mass, on the other hand, stays the same. Doesn't matter where you are, your mass is always exactly the same. It's about the matter inside. So it's how much space you take up, how much mass you have. Right? Your matter never changes. If I'm here on Earth with you guys right now, my matter would be exactly the same as if I got to go to the moon. Right? Alright, then the main event for the day, our equation. Okay? In math class, you do a lot of algebra. If you've taken algebra, you've done a lot of algebra, or where you do solving for x and y. We're not really going to do that in here. Right? In science, a lot of times we use an equation and you just plug in numbers into that equation over and over and over again. This is our equation. Right? Density equals mass over volume. Right? If you like this kind of stuff, you can take physics. Physics is all these mathematical problems that are science-based. Okay? But again, we'll never be using x's and y's. We'll just use different units, but you can probably guess what these mean. Okay? Density starts with a D. That's what the D stands for. M is for mass, and V is for volume. We always use units. Do not forget to use units. If you've ever taken a chem class, you know your chem teacher will like die for the units. We kind of got to be the same in here. Okay, grams per cubic centimeters is going to be our units, or G over centimeters cubed. Right? Sometimes it could differ, but generally you're always going to see grams per centimeters cubed. Okay, so again, density is D, M is mass, and V is volume. Something I want to point out real quick before we move on. Alright? In every single one of these problems, you're always going to be given 2 out of the 3 variables. So if algebra is not your strong suit, I would write this down. Okay? You're always going to be given 2 variables. So if you're given mass and volume, and you need to solve for density, you would use the regular version of our equation. D equals M over V. But there's going to be instances where you may be given volume and density and not mass. Right? The way the first equation's set up, if you're given density and volume, it's not going to work out for you. Right? So you need to change the equation around. Right? So if you're given density and volume, it would be density and volume equals mass. Right? And lastly, if you're given mass and density, it's going to be mass divided by density equals volume. Again, if you are strong in algebra, you can just plug it into here, like cross multiply and figure it out. If you are not and you feel that you may need these, I suggest you write them down. Okay, because there are going to be, every question's going to be different. You're not going to be given mass and volume every time. All right, so this is, I'll leave this up here.
Isn't it in the triangle? Isn't it V?
Yeah, you can do the triangle thing, but I don't like that. But
Oh, okay.
okay, here's an example of the type of questions you'll be given about density. And the reason we talk about this in earth science is when we get into talking about rocks and minerals, you're going to find that every single rock and mineral has a specific density. Right? So every block of gold, every block of silver, they're going to have the same density because every element has a specific density. So we're going to practice before that, before we get to rocks and minerals, with word questions like this. So if you want to follow along up on the screen as we go through this, these are the types of questions you're going to practice today. Let's say Miss James buys a new pencil case. Love me some pencil cases, okay? It is 3.2 grams and has a volume of 0.4 cubic centimeters. Okay, so you've been given two pieces of data. You would then be asked to calculate the density of my new, nice blue-colored pencil case, all right? So what you would do first is you'd identify your two variables. In this equation, we're given volume right away because it says the word volume. Okay, 0.4. And we're given a mass, 3.2 grams. All right. Once you have this information identified, you can then easily plug it into the equation. Okay, so volume is 0.4, mass is 3.2. You know mass divided by volume is density. You would take your 3.2 grams divided by your 0.4 cubic centimeters. You would then result in your 8, because 3.2 divided by 0.4 is 8 grams per cubic centimeter. All right. Don't forget your units. Keep that in mind. If you don't put your units, your answer is not correct. All right. So another little flow chart that shows you. But this is the type of question you are going to be getting. You'll be given two things. You'll need to find the third. Okay, we're going to watch a short little video. It's like 3 minutes here. As we're doing this, I'd like you to watch the visuals that they give you. When we talk density, it can be kind of hard to understand what exactly it means, how it's different than weight, how it's different than mass. But this should give you a little bit of a better idea. So let's try this out. This little penguin going on.
A can of Diet Cola will float, and a can of regular cola will sink when placed in water. You see, in the same amount of fluid ounces, there are more atoms in a can of regular cola. The main ingredients in cola are carbonated water and sugar. So each can has the same amount of water molecules, but in the same space, the regular cola has additional molecules from the sugar. Putting more atoms in the water forces the molecules to be more dense, making the cola sink. Hot air balloons fly because of density. Just like all matter, air is made up of atoms and molecules. When air inside the balloon is heated, it expands or gets bigger. So compared to the air around the balloon, the atoms inside have more room to move around and as a result are not as tightly packed together. The air inside the balloon is less dense than the surrounding air, and the balloon becomes buoyant. When it's time to land, the pilot stops heating the air, and as it cools, it contracts to match the density of the surrounding air. The effects of gravity go to work and bring the balloon down to Earth. If an object is cut in half, its density remains the same. Take a look at a gold coin, made of neatly arranged gold atoms. When cut in half, the tightness of the atoms does not change. Whether you have a half of a coin or a complete gold coin, the density stays the same. The density of liquid water is 1. Objects with a density of less than 1 will float, and objects with a density greater than 1 will sink. Take a look at these 3 objects. All of them float, so their densities are less than 1. But if you take a closer look, you see that as density increases, more of the block is below the waterline. Scientists have figured out the density of a block converted to a percentage is equal to the amount below the waterline. For example, if 75% of a block is below the waterline, its density is 0.75.
Grams per kilometer squared.
Ice floats because of density. When water freezes, it expands. Just like the expanding air in the hot air balloon, water molecules in expanding ice spread further apart. The atoms in ice are not as tightly packed together as they are in the liquid phase. If we observe an iceberg, notice about 92% of the iceberg is below the waterline. This means that the density of ice is 0.92. Density facts. To learn how.
No, we don't want more. Okay, so there you have it. Only one last thing I want to point out to you from that video is the density of water. Okay, you are going to need to know this by memory, but I have no doubt you're going to be able to remember that the density of water is literally 1. Okay? Yeah, I know. Really tough one. Okay, so we're going to do a lab where you're going to need to know the density of water. Okay, so that's why I'm presenting it to you now. All right, we can compare densities. Many densities throughout the world are already known. So it's like set in stone density. A lot of rocks, a lot of minerals, which again is our next unit, have a specific density to them. All right, so it can tell you information. It can help you identify rocks and minerals. One of those sets on record is water. Okay, so water's density is 1 gram per centimeter cubed. It also allows us to have buoyancy. So just like they said, the hot air balloon is buoyant in the air, you know, it's like suspended. Same thing can happen underwater. Okay, the suspension of items
So
in
isn't
water
air
is
0.1
possible because of the
grams?
density of 1 of water. So just, you know, keep in mind, you can automatically know the density of an item is either greater or less
air
than
would
1 if you put it in water. If you drop an item in a bucket of water and it sinks to the bottom, you know its density is going to be higher than 1. If it floats on top, it's going to be less.
Which one's heavier?
Okay? Any questions on any of this stuff?
Other than dense
You ready to do some math?
No, I feel how light
Okay,
it is.
I'm gonna turn the light on here. Right, you're gonna need something to write with. You're also gonna need something to do some calculating with, whether that be your Chromebook or your
Feel how
phone.
heavy is this?
because it's plastic around it.
Just like how that one person tried to change their
Okay, we're gonna spend the last, or you're gonna
their
have the last like
race to,
20-ish minutes
British
today of
to,
class as work time to
Korean.
complete this practice, density practice worksheet. Okay, there are 8 questions for you, alright, and I would like you to go through.
Did some new plastic surgeries to make himself look Korean. And he basically was like, look, I have a flag. Look, I'm Korean. See? It's blessed in Korean holy water.
Korean holy water.
Korean holy.
How many Koreans do you see as Christians?
None.
Yeah. It's not racist, it's just true.
Yeah, he actually named himself after one of the BTS.
No, he did not.
Yes, he did. He named himself Jimin or something.
Gosh.
He looks hella. What?
You watched the Good Fight?